Hello, everyone. Thank you for coming. My name is Zoran Horvat. Today I will show you some code that helps manage multi-tenant databases when you're writing applications that use entity framework. The trouble with the multi-tenant databases is that today most applications tend to implement multi-tenancy in a single database because that simplifies management, deployment, and many other things. But unfortunately, that opens up a lot of space, a lot of surface for attacks and incidents, unintended features of the application when one tenant accidentally can see or even modify somebody else's data. And that is tragic for multi-tenant applications. So we will talk about how we can protect, how we can secure database infrastructure layer in 3 ways. One will be manual, so to say, when you are trying to write code which is secure. The other way will be using global query filters from entity framework. And the third and most complex method will apply a custom wrapper around entity framework classes, DB contexts, which will enforce security models. And you will see the idea is to, in the end, turn security models into declarative coding style so that you merely say which kind of security a certain page or certain class requires, and that will be injected for you. There will be plenty of code, and you can download code from GitHub. There are 4 stages, 4 separate solutions there, and you will be able to track how each of the security models, security implementations copes with the problems in this application. So, the application. The rest of the presentation will be in Visual Studio. Those were all the slides I prepared for you. There will be some products in this model. These products will be the item we are concerned about, and there will be many attacks and bugs related to securing access to products. That's the only model there is in this application, and that will be sufficient to show you all the aspects I wanted to talk about when talking about security. Every product is owned by somebody. There is no auto-increment ID foreign key to the user who owns the product for several reasons. One of the reasons being that we don't know where that user is stored. If you look at code, you will see that authentication contains user and content namespace contains product. I did it on purpose because I want to show you that users might be stored in a different system, in a different database schema, which might or might not even be in this database. So I'm referencing users by some unique key which is assigned to every user on registration, and I'm passing that string to all those who are concerned. Products, of course, are concerned, but as I am in parallel to designing databases, I'm also an object-oriented programmer. I don't like to send strings around. I have introduced some class named userRef that is the object which uniquely identifies a user in this object model. This string above is required by entity framework to store products. And this is the user class. It also exposes the key which is string for the reason of storing users in the database in entity framework. But again, it is initialized with a strongly typed user reference. And this is that user reference class, which only wraps around the string. So I have set up the stage, and I'll run the application. Okay, here it is, so that you can see what it's doing. If I log in as me and I click products, I will see the table containing products. I'll be able to see any of them or to delete them. I can also insert new ones. The problem at this stage, there is no multi-tenancy implemented at all. These 3 items really belong to me, and the other 3 items belong to my neighbor, another user. So I don't have neighbor, I don't have multi-tenancy implemented at all. You see, both of them can see the entire database. That's not what we normally want. So now from this point on, I will first try to implement any kind of access control so that I can manage to display only those items to the logged in user which that user possesses. Before that, I will add some more HTML so that you can see what's happening in a database when this application is executing. I will run it again, and look, when I log in, we will track queries made by entity framework. Here you will see excerpts of the log. This is the query generated to authenticate me. I'm not using passwords here because it's not a point to show you how you can authenticate. This application is using only cookie authentication, but again, that's not relevant. This presentation is not about authentication. I presume that authentication was done and that requests were made to the infrastructure layer. That is where my problems begin in this presentation. So here is the login. Then content context. Remember, content is that namespace where products are. Don't mix content and context. I'm not happy with choice of names I made here, but that's how it is. Content is what we are protecting, securing. So the context will be, model will be created, and then comes the select query, which lacks where clause. And technically, when you're securing data, you're securing them by supplying a where clause, which is narrowing down the query so that you can only access those things that you are allowed. And what you are allowed, that is what where clause will tell. But that's not all. There is one tragic circumstance here. If I go to details of one product, there is a query where ID equals the parameter. Technically, ID is taken from the URL. I have done the worst possible thing here by using auto increment ID in URL. Don't do that. That is naive on several levels, only one of them being security. If you make, IDs, you will always have to put some reference here, or otherwise you won't be able to find the object for which you need to show the details. That makes sense. And since that is publicly visible, we cannot tell that ID or reference is a secret. It's not a secret. It is semi-public. You don't have to walk around and tell others what your IDs are, but as a programmer, you cannot assume that nobody will be able to guess IDs of somebody else. They will find the pattern and they will apply it. Attackers will apply patterns to poke into your website by guessing IDs, among other techniques. And while you cannot defend from that, you should not make their job trivial by using auto increment in IDs in URLs. That's simply not the best idea. There is one funny story that I wanted to share with you. Many years ago, I was on a project where we faced the need to put some references in URL, and we immediately dismissed auto increment ID on the grounds of industrial espionage. We figured first that our competition will know precisely how large our business is if we put auto increment IDs in URLs. It's very simple. The competition can register in regular intervals, register new users, like once a week, and simply count how many IDs you consumed for users. And therefore, they will know immediately how many new users you're acquiring every week. And they could make one single purchase every week and see the auto increment ID of the receipt and see how many receipts you're issuing every week. And even by looking into details and finding out IDs of the legs inside the receipt, they could even see how many items you have sold. So those are parts of the security theory which you should also keep in mind. But again, it's not about securing IDs, because sooner or later attackers will know them. It is about securing the system here in the where clause. And forgetting to do that, you will open up your database to people who should never see this object. If your infrastructure layer allowed where clause by ID with no end plus some other restriction. And you will see that happen in a second, because here's that page, which is listing products. And this is how I'm getting to products. I'm doing nothing. I'm just taking the DB context, which was injected, and asking for products. So there's obviously no where clause here. And what many programmers first attempt is to add the where clause. So are we safe now? I'm only listing products where product owner key equals authenticated user, and the value picked from that object. This get authenticated user is just an extension method, nothing special. I made this extension method to operate on HTTP context, which is very useful in pages. And it simply looks for the name identifier claim. And if it finds it, it will wrap it inside my strongly typed user ref. Otherwise, it will go with an empty user ref, which will, when used inside a where clause, cause that no product will show up if nobody is, for some reason, logged in. Which reminds me to tell you, when is this extension method going to be invoked? Well, obviously from pages that have access to HTTP context. So why this branch? Why am I plugging the else branch when there is no claim such as this? Because while my entire application is built to never allow access to pages where authentication was not performed to the end, you can never trust yourself as programmer. Sometimes you will forget to mark some pages as requesting authentication, and you will get to this call from an unguarded place. You can throw there, or you can do many things What I did was to ensure that no product will ever be found in this where clause if there is no name identifier claim. And by doing that, at least I have prevented tons of data pouring into the UI unprotected. Do these small things, these small protections everywhere in your code. That idea is called defense in depth. The point is that you never know who called you, even if that is your own code. Because when this get is executed, you cannot tell that everything that was intended to happen has happened indeed before this call. Maybe you have a bug upstream and you got into this on get action accidentally. So the defense in depth is trying to prevent any breach on any level, on any layer. You will protect yourself everywhere. And so I did that with this where clause. And I think I might be able to start this application again and enjoy it being secure this time. Can I? Oh, yes. There are only 3 items here. Those are my items. And that is what this where clause is telling. Where owner key is the parameter, and that parameter will be taken from HTTP context, and that will be me. However, the problem remains that I am still selecting details by ID. Someone might say that the problem is in the UI. Why would the UI show a URL to something that doesn't belong to some ID that doesn't belong to me? But the problem is more is larger, because it's not only what I'm showing in the UI. There will be people who will forge requests. Here is this row with 1. I'll call it hacked now. I can forge the request and say, why not delete something? Okay, if there is ID 1, maybe there is ID 6. And I can even check it with URL to see the details. Can I see the details of ID 6? Let's see. Yes, I can, because my application was only selecting by ID, and that ID did exist, and I forgot to add another where clause to this query. I simply forgot, and that will have a tragic result when I click that bin. Here is what will happen. The application will select by ID because it was told so, and since it will find that object, it will delete it again by ID. Both statements are making the same mistake. They are only accessing database by ID, which is totally unsecure. And then it will happily show me my products, but the problem has already appeared. Neighbor, when neighbor comes back, the third item is missing. So I have successfully deleted somebody else's data. And that shows us that this approach, where you add where clauses everywhere in your application, is not such a bright idea for a very simple reason, because you will forget to do it in every single place. In an application which has thousands and thousands of such methods, a couple of them will remain unprotected, and guess what? Somebody will find them. So I will advise against doing this. Don't protect your data like this, but apply something smarter, something that will come with a guarantee that it will happen, no matter what you did. Entity Framework is coming with an implementation of so-called global query filters. what was the where clause I put here, you can put that where clause right in the middle of your DB context, so that the DB context is forbidden to access any data that do not belong to you. Effectively, it will contain that where clause. So let me show you how that can be done. To separate concerns in this application, I have prepared a small class called tenancy provider, which is wrapping HTTP context accessor and simply calling that extension method on it. So basically, if you injected this class, you could depend on this class instead of HTTP context accessor, and still you will be able to get grasp of the user ref, which represents currently authenticated user. And then you get to the DB context. Here is the DB context, which is exposing products. In this DB context, I can inject tenancy provider. But listen, there is a subtle game going on about lifetimes of objects. Tenancy provider is injected as a singleton because it is stateless. I had no reason to make it, to let the system instantiate it multiple times. However, when working with multi-tenant databases, whenever you receive a request over the web, there might be a different tenant authenticated right now. So you need a new tenant every time DB context is instantiated. But there is a terrible issue there. On model creating, that is the place where we will add that where clause. On model creating is executed once per application. And that is because of performance. This method is heavy, can be heavy, it's complicated, and therefore the model it creates will be cached and reused, and that will affect the where clause, which will also be cached. If you want to inject dynamic where clause, you need to create a property on the DB context, which might change every time the DB context is instantiated. And you do the easy way to manage that property is to set it in the constructor. And you would normally make DB context short-living object. You would create new DB context with every web request. And you can use tenancy provider to tell you who is authenticated right now. And when DB context is instantiated, this property, authenticated user key, will have the value of the key to the user who is authenticated right now. And it might be different with every request. And so we get to the on model creating, and we add global query filter. It is done by using this has query filter on entity descriptor and giving it an expression. So we want a product, its owner key property, to be equal, or field in a database, to be equal to what this DB context thinks right now. And that is all. Let's run the application. If I log in as me, I see products. There will be only 3 of them, even though the page, not this one, the page did nothing to select them. Where is the page? Okay, page did nothing to filter them. It was the entity framework who did it for us. Here, logging in, okay, checking my username, and then happens on model creating, the first and the only time for this DB context. And when it executes, it will include the where clause, which I never made in consuming code. It will be set to a parameter. Here you can see it's telling us the name of the parameter. It is the authenticated user key from DB context class. If I tried, just 1 second, remember on model creating was performed. If I click again, products, there will be no on model creating again. So it is executed once. If I tried to access, okay, I can access my own products by ID, but look at the where clause. It also contains where owner key is my key and ID equals ID. And that is secure. There's no way for me to see somebody else's data. And if I tried to hack the application again, to forge the request, let's do it. Let's try it. Hack. I know that that guy had the ID number 5 and here. So I'm changing the requests. Here, there's nothing. I couldn't see the product. Even though the page didn't explode, that was my conscious decision not to explode. But there are no data. Nothing came out from the database because where clause once again contained where owner equals me and ID. And since I'm not the owner of this ID 5, I couldn't see anything. Nothing came back from the database. And what is more important, this delete is for somebody else's data. Look what happens here. Where is again composed of 2 elements, and that returned no object, and therefore in between these 2 statements there is no delete statement because there was nothing to delete. Again, it was my conscious decision not to do anything, but I could scream, I could explode, I could write to log that somebody tried to delete something that is not accessible. You can do anything you want in your application. What is the point here is that the infrastructure layer didn't hand me over the object which I'm not owning. And this is the regular where clause to show everything I have. So that is how global query filters work. They are great. They have one wonderful feature, and that is that they consist of a single line of code. And that single line of code affects every query executed through this DB context on this model. This scales very good. You might have dozens of pages that are showing products in different ways, and there will be only one query filter for them. So that is great. That is one single line of code to fix it. And that is also the doom of this whole idea, because this one line of code is placed where it should not be placed. It doesn't belong here. And you will see that when I tell you the rest of the story. Products are not the only table I have. I have another table called friend connections. My customer wanted to let users tick other users as their friends. And when I am a friend of somebody else, then I can see the products of that somebody else. But there is a comma after that saying, but I'm not allowed to delete them. And you will see that that cannot be done with global query filters. So I will add dbset so that it can be used for this context, but I'm not going to use it. Really, I'm only going to query. This is the friend connection model. It only has 2 fields in the database, owner and his friend or her friend. So what happens to the global query filter with these enlarged requirements. For one thing, we cannot filter by owner anymore because owner is not the only one whose products I might see. There is the whole new expression here, which will list all user keys whose products are accessible to me. So it is obviously me plus friends where I am the friend. I will call this reverse friends in the rest of the demonstration. So people whose friend I am, and then I will pick their key so that I can see their data. And when it comes to the filter, it will look a bit differently. The owner key of the product must belong to the list of owners whose products I'm allowed to see. That is as per requirements. Shall this work? Products. Here I can see my and my neighbor's products because this will first execute the query on friends to find whose friend I am, and then construct the list of keys whose products I'm allowed to see. I'm allowed to see my friend's product, obviously, because that query by ID now consists of checking whether the owner belongs to the list and ID equals what I asked for. What is the problem here is that I am completely free to delete my friend's product, which I shouldn't have been allowed to. Here, it is also selected to belong to the list of owners and ID, and this where clause is satisfied, and subsequent delete statement ensues. This delete statement works by selecting by finding by ID. That is how Entity Framework works. But if you remember, you need to give DB context an object, an entity, and ask it to remove that. So the security of that operation is executed in this way. The select query for the entity which you want to remove must not return that entity if you're not allowed to delete it. And then you will have nothing to pass to the remove method. That's how you secure that, which failed me here. This doesn't work. Someone might argue again that the problem is that my UI is showing the delete action, but that's not the point because I can always forge the request. If only I knew the ID, and now I know it because the UI is telling me ID. So this is the doom of global query filters. There is only one global query filter per DB context per entity. And if you have multiple security models for that entity, you cannot do that here. You might choose to create two DB contexts accessing the same data, but I wouldn't walk that path. As I said, the problem with this line of code is that it is located where it does not belong. Instead, what we engineers normally do when we face a situation like this, we over-engineer it. The point is that we need to pull this where clause out and wrap the DB context into a wrapper which contains the where clause, so that we can create two wrappers if there are two possible where clauses. And that is what I will do precisely. So there will be no global query filter here, which I'm sad, really. This really scales very well. But again, doesn't support multiple security models. So I have removed dependency on that tenancy provider, and I will remove both of these properties. I have my naked DB context, which has no logic regarding a security implemented, nothing. So it is not, it should not be allowed for any consumer to consume this directly. Instead, I want to wrap this DB context into something that will add security layer on top of it. And we normally do that by introducing interfaces, because interfaces are only defining signatures of methods, and we can make that DB context implement interface and some other wrapper implement interface and apply that wrapper around that context. So this is the DB context that allows reading. What does it do? It can query and it can find by key. That's what entity frameworks DB contexts normally do. And I might define the writing DB context. It will be more rigid. It will allow you to add some entity. So there will be a write DB context per entity, but that doesn't mean that you're not allowed to implement this interface multiple times for different entities. So you can still have multiple entities exposed through the same DB context by specifying this write interface several times for several generic arguments. At the same time, you can read anything you like. And here we see the limitation of C# programming language, because it's not possible to do this or to move this over here. It's not possible, because then you might not be able to support multiple entities per DB context, because this method would only differ in return type, which is not allowed in C# language. That's how it is. And the same stands for find. You can find any kind of entity using any kind of keys, any number and types of them, and that will produce something. DB context in entity framework works the same way, and they solved the same problem in this way. All right, writing DB context. I can add, I can remove, and I can save changes. That is what DB context from entity framework are doing. Notice that by implementing these, preparing to implement wrappers, I'm not hiding away the fact that I'm working with entity framework. This interface depends on entity framework. This type is defined there. It is mimicking the process of entity frame of how DB contexts work in entity framework. Save changes, returns integer. Here find. This is the signature of the find method in DB context, and so we can start implementing this. We can be kind to ourselves to also implement an interface, declare an interface which is both reading and writing context. So that content context would be this one. This this is probably the point where you have started losing the thread of this talk, because there are many brackets, many types and parameters here already. Download code, read this. It's very simple in the end if you just get a grasp of what types I'm using here. And I might go even one step further and say that content part of my database, why not declaring an interface with the default getter implementations, so that nobody has to deal with these cryptic methods. You can be as good to yourself as much as you want, but the essence is that now that we have all these interfaces, we can force the DB context to implement them. And by doing that, it will immediately become subject to future decoration. You will be able to implement thin decorators around any DB context and add security to it. What does it mean? Okay, I have to turn this into iQueryable. That's the only change. What does it mean to implement these methods? I need to expose this query all for any entity type. I don't have to implement find because base DB context from entity framework has precisely that find method I asked for. I can add and remove products. I can add and remove friend connections. I don't have to implement, where are you? I don't have to implement save changes because again, it is declared there defined in the base DB context here. So I have satisfied interfaces. And when I have interfaces, I can play with them. I can make consumers of DB context more narrow. They can start expressing their desires more specifically. This is the index page, which is listing all products. What does it need? It needs to read and nothing else. So it can depend on content, read, context. Everything below compiles the same. Remember, there's no where clause here, nor will anyone put it here right now because I'm still injecting that content context. But you see that the climate is changing. I can express desires more specifically. And in only 5 minutes from now, that will let me inject specific security model, not just database model, but security model. All right, details page, same thing. Just allow it to read. What about deletion? Page which deletes will require the entire DB context because it wants to read first, it needs to find by ID, and then to remove, and then to save. Therefore, it needs both reading and writing capabilities. But for instance, insert model, page which is inserting new items, only needs to write. It reads nothing in this application. Of course, this part of the application, pages, is 100% custom. That is where I'm implementing application requirements. That side of the application where I defined these interfaces is semi-general. This is quite general because it is generic, and I have that specialization for the content DB context. And in depth, into the infrastructure layer, things are becoming more and more specific to specific schemas in the database, parts of the schemas. They're operating on specific entities using their own intricacies, like products having owner. Not every record in my database has the owner. So you will see a complete separation of concerns. Where is the application logic in pages and models that are located there? Where is the infrastructure security in the infrastructure layer? Nobody will have to think about that except to express intention. What security model they require. And I will show you where classes are located in the end, and you will see this separation. And right here, I already have that separation starting to emerge, but that is not enough. There are no where clauses here. I start the application. There is no multi-tenancy implemented at all. Here, there's no where clause. I can see the entire database. So this is the moment when we start installing where clauses. our own query filters, which are not global anymore, but per object. This is the moment when you read requirements and you ask your customer, what do you want regarding security? And you figure that there are two security models in this application, in the requirements for this application. One I have called assigned content reading context. This word assigned and content, that's the crux of it. Customer says some content will be assigned to a user and user can do what? Read that, not write. And there's another model, full ownership. That is, suppose that is how customer called it. Full ownership means that I'm allowed to do anything with the item which I own, which comes out from this context. So the point is that I have simply named specific wrappers by the requirements. And I expect each of these to implement what is required explicitly. And I did develop these two classes. And as you may guess, 90% of code was duplicated. So I pulled that code into a base class. And now in this demonstration, I will effectively implement base class first to make it, explaining it shorter. I called it tenancy content context to indicate that this is the base class for all classes that are implementing tenancy concerns on the content. And look at this. I still haven't implemented any of the interfaces. That will come in due time. This base class will wrap around content context and keep information about the authenticated user in that same way in which I did it before with global query filters. So it will ask the tenancy provider whenever it is instantiated, and it is instantiated once per web request, to tell currently authenticated user. And then comes the magic. What is this class going to do? It's going to narrow down what products can be seen. And I will make an abstract member, which every derived wrapper will have to implement. I need an expression which turns product into Boolean given the authenticated user. That's how it becomes dynamic. And it is expression because I plan to use it in iQueryable. I will use it in iQueryable possibly multiple times, so I will materialize this expression by effectively calling that abstract method above for a really authenticated user. And I will make that lazy because I might use it multiple times through the lifetime of this DB context wrapper. And therefore, this method will only execute once. It will construct an expression for me, which I can freely dump into any and every query I make. But I will do more than global filters, query filters could do. I will also check for inserts and deletes. That's what the global query filter cannot do. It can only add where clause to queries. I will also compile this expression into a func delegate. And now I have two natures in this wrapper. One nature is the expression which can become part of iQueryables so that Entity Framework can construct optimal queries for the database. On the other hand, I will have a func delegate, a predicate, which turns product into Boolean, where I can perform that same question in memory whenever I see an object. And then, how do we get products, for example? By querying all products and appending where clause as specified by the derived class. This is how we make global query filters flexible. They will be specified per object, not by per DB context. What else? I can get friends, but since I didn't have any specific requirements about friends, I didn't have to repeat this here. Okay, I didn't have to add 3 more members for friends. I don't have any request about that, because there is a fixed query for who are my friends. Those are where owner is the authenticated user, and there are those reverse friends, whose friend am I, where friend key equals authenticated user. In this way, whoever called, all these methods are protected. Now, any derived class can get friends or get products, and only receive the result of the query, which includes where clause as per requirements. That is the most important part. But what else can I do? I can get entities. Remember, this strange cryptic method exists in those interfaces. I can get entities by checking the precise type and using a precise method to get products or friends, and in that way enforce this general method to include where clause in every query. And find goes the same way. It will use these secure methods. What else? Adding a product. Now the things will become more interesting. How do we add a product? I will apply that predicate, which is equal, which is a compiled expression which is used to query the database. And only if it returns true will I add it to the DB context. That is security. But what else? There's a trick here. There's the as branch. That is something that global query filters don't have. Else, take the biggest red letters you have and write into the security log, not just into any log, but into the log where only authorized personnel can see what went wrong, and write that somebody has got the product that doesn't belong to him or her. All right? So this is custom security applied to products the way our customers have requested. Don't let anybody add product that belongs to somebody else. I can do the same thing in removal. Also, if I'm authorized to remove the object, I will do that. Otherwise, this is the security breach. This means that there is a bug somewhere in whoever called whatever layer was called. There was a bug there. That call shouldn't have happened. And this is the place where I stop propagation of such bugs. I can also do the same thing for friend. This is what? Insertion, deletion. These 4 methods obviously have quite a lot of duplication. I could have dealt with that, but I was too lazy to do that. And in the end, there is the internal save changes method, which only passes call to save changes on the wrapped DB context. I was careful to not reuse method names for any of those interfaces because I want to implement them here. Assigned content reading context will derive from tenancy content context and repeat that. You remember that query for reverse friends, and here is the where clause. This is that same where clause when I'm allowed to see anything that belongs to me or to people who declared me as friend. And what interfaces will this class implement? Only the reading interfaces. That is what customers' requirements are. I can only query and find. And look at the full ownership. It will also derive from tenancy content context. But here is the where clause. That is that other where clause I had. Full ownership means that I can only see products and change that I own. It will implement all the interfaces. I can read and write. So this is query and find. Everything is all right. This is add, remove product, add, remove, friend connection, save changes. Everything can be done, but with a different where clause. And how does this work when we get to pages? Pages will now request a specific security model. Index page only reads and it applies the assigned content security model. Fine. Details, the same. But delete requires full ownership. Insert requires full ownership. And this is the last thing in this code where I have turned security declarative. These are the pages. Pages contain absolutely nothing except constructors and interfaces they depend on. Everything is implemented here in the infrastructure where interfaces are pretty general except this one, which is specific. So I could push these specific interfaces into some subnamespace and turn them into the API of the infrastructure. And these specific interfaces, where is assigned and where is full and where is content reader, this is the API of the content part of the database. And technically, others would only depend on that API. They would never, ever touch content context. And by doing that, you will secure the database. Let me show you how the application works now. This is me. There is the where clause. It works the same as with the global query filters. It selects friends, builds the list, and adds it to the where clause. If I try to see my neighbor's product, here it is. I have the right to see it. But when I accidentally click delete, you will notice that there will be one where clause to find it for deletion, and that will not return the object. There will be no object. It will be there will be no delete statement here. But when I want to repopulate the list, I will be back to the second where clause. Let this image be the last thing I will show here. This is how you can implement multiple where clauses. Unfortunately, I have eaten all your questions time. Please go to Slack and write questions there and tag me so that I can see it. Is there a way to pass Azure AD access token to Azure SQL Enforce? That's the Ashit. That is the question for authentication part of the application. So keep that separate from infrastructure, and you will succeed. The time is up. I'm sorry that I left you without questions, but write them in Slack and I will answer them. Thank you, everyone.